Auzubillahi minash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum, dear students. Myself, Aumair Taj. I am working as a physics teacher in Army Public School and College, Patwar Complex, Boys, Islamabad. Today, we are working upon the grade 11 subject physics article equation of continuity. For the better understanding of equation of continuity, we first of all we have to understand its basic concepts. And basic concepts starts from its name. What is fluid dynamics? Fluid stands for all of those things which can easily flow. Fluid flow. Those things, those types of fluids which can flow, and during their motion we understand their properties, we understand related laws with them, we understand the equations related with them, and this category, this branch of physics is known as fluid dynamics. So if we understand, or if we have to discuss it into more categorized form, we have to study a substance which flows is called fluid. So if we divide it into two parts, and number one is hydrostatics. When we study the fluid at rest, the properties related to fluid at rest, this is known as hydrostatics. And when we study the fluid in motion, during motion, and this will be known as fluid dynamics. This is basic branches, basic definitions of fluid flow, and this is helpful to understand the equation of continuity, which is actually or exactly our article. And viscous and Stokes law, if we have to discuss a little bit for betterment of understanding, we have to discuss two more things. Number one is viscosity. Viscosity is basically the frictional effect between the layers of fluid flow. In our this is basically a chain. In our ninth grade, we understand the opposition, the word actually opposition between two surfaces will become as friction. When we move in 10th, we understand the opposition between charges is known as resistance. Similarly, the opposition will be changed in first year, and the opposition between two layers of a fluid flow, when the fluid is flowing, and the opposition and the resistance between two layers of fluid flow, it will become viscosity. And here the fluid flow already have two more examples. One of the is linear, laminar, steady flow. And steady flow, here we are discussing this thing in steady flow or laminar flow 6.4, that kind of flow in which all particles of a fluid flow moving from same point, same direction, in same way. And the other one is turbulent fluid of flow, which is irregular fluid flow. The motion of fluid flow is irregular, disturbed, disordered, is known as turbulent fluid flow. And the one thing more which is more important, we are starting our actually or exactly our article, which is equation of continuity, we have to understand, and which is the ideal fluid flow. What is exactly ideal fluid flow and its conditions? Number first, if we are going to study, the fluid is non-viscous, which means there is no internal friction between, just as if we are going to understand the ideal fluid flow, there are three conditions. Second one is the fluid flow is incompressible, which means its density remains constant. The fluid flow is incompressible, it means its density is never going to be changed. The third one, this fluid flow is always laminar. The steady fluid flow is always preferable as an ideal fluid flow, working. So now we are going to move our basic article, which is equation of continuity. Here, if we want to actually understand the equation of continuity, we have to learn about its diagram first. Its diagram, there is a pipe which has two ends, and the fluid will be flow in this pipe. It will be move in this pipe. So it has two ends. One of them is lower, the other one is upper. So if we define, it has two definition. First of all, it's in our wording, which is the product of fluid, the product of speed of fluid flow and cross-sectional area of pipe at any point in the pipe. When the fluid is flowing in the pipe and pipe has some cross-sectional area, the product of cross-sectional area of pipe and speed of fluid flow at any point which is equals to constant. Its basic definition. If we have to just understand this, A1 V1 which is equals to A2 V2, we are basically discuss this equation. The product of cross-sectional area and V1 is speed of fluid flow at any point which is equals to constant. Now we have to move back our the other one definition is the principle of state that the steady state flow, the mass flow in the volume into the volume must be equal to the mass flow rate out. Consider ideal fluid, sum the fluid flow the pipe, non-cross-section area, non-uniform cross-section areas. The fluid of the same mass is flowing steadily between two stationary. The other one is, we will prove the equation, then we have to do the rate of fluid flow which is equals to constant. The first statement was the product of cross-sectional area of pipe and speed of fluid flow at any point which will be equal to constant. This is known as equation of continuity. Other definition is the rate of fluid flow. We have the equation which is equals to the ratio volume to time which is equals to constant. It is the other definition of fluid flow. So we have to move in our equations. We have to understand the first equation is distance. Our ninth formula which is equals to formula of speed which is equals to S which is equals to V cross T. We are discussing this first equation, S which is equals to V cross T, where S is distance, V is speed, delta T is time. The other equation will be moving toward its volume. So volume which is equals to area into distance. So delta V which is equals to S into A. We are introducing S1, A1, delta V1 because we are working upon the lower end. The same working will be for the upper end. So delta V1 which is equals to S1 A1. We have the value of S1 which is equals to V1 delta T. We put the equation, we put the value of S1 into this equation. So delta V1 which is equals to A1 V1 delta T. So this is our equation related to volume. Similarly, distance traveled by fluid passing through the A2. So similarly, the same equation, our first equation is developed, generated delta V1 which is equal to A1 V1 delta T. The same equation, this is equation for lower end. For the upper end of the pipe, equation will be delta V2 which is equal to A2 V2 delta T2. So these two equations for volume, delta V1 delta V2. And if we move the down mass of incompressible fluid, we already studied the ideal fluid flow must be incompressible. Incompressible strength for its density is never be changed. It has constant value of density. So as we know the formula of density which is equals to rho mass per unit volume. So if we move toward the mass, so it will be delta M1 which is equals to rho delta V1. We already derived the value of delta V1, so we put in this the value of delta V1. So equation will be delta M1, delta stands for small chain, so which is equals to rho A1 V1 delta T. This is our equation of mass which is for lower end. So similarly, the mass of fluid for upper end, we don't have to derive it properly. We just replace the symbols from 1 to 2. So it will be delta M2 which is equals to rho A2 V2 delta T. Now if we introduce some more important feature in it, if we want to if we want to understand the what is mass flux, here the delta t which is product with the v1, if we divide delta t with delta m to delta m1, then it will become the mass flux delta m1 by delta t, delta m2 by delta t, which will become mass flux. We are not introducing, we are not using here, but the students should know what is mass flux. Anyone ask you about have you studied the equation of continuity, you replied yes, and he or she can ask you what is mass flux, you will blank. So mass flux is ratio of mass by time, fluid mass. Now we compare these two equations. So we have delta m1 which is equals to delta m2, so rho a1 v1 delta t, rho a2 v2 delta t. So rho is constant, delta t time is constant, we cancel out them, we left only a1 v1 which is equals to a2 v2. This is proved equation of continuity. The product of cross section area, speed of fluid flow which is equals to constant. So finally we proved it, we got our equation. Now if we modify our equation more, so we have to replace our speed with volume, where s equals to v cross t, v which is equals to s by t. So if we remove v by s by t, then we find a into v, a cross section area, and volume which is equals to delta v by delta t, which is equals to constant. So the rate of fluid flow, here we have the equation, this is constant, this constant is equals to the time rate of volume of liquid flow through the pipe. So we have to ratio the liquid, the time rate of the volume. So we have proved, we have find the first equation which is equals to a1 v1, the a1 v1 which is equals to a2 v2, or we can write it a cross section area, v speed of fluid which is equals to constant, and the second equation which is equals to this we are here mentioned is equation number 6, delta v by delta t, the rate of fluid flow, the rate of volume of fluid flow which is equals to constant. So we have proved our equations. We have if we worked upon, then we have to compare these equations and working upon these equations. Then further, if we study the speed of fluid flow, any pipe is inversely related to cross-sectional area. Where the cross-sectional area is larger, speed of fluid flow will be smaller. And these two terms are inversely related to each other. I hopefully you students got the equation of continuity. Allah Hafiz.